4 cosine 20t, leave a space on the top. It is a voltage source this is 2 ohms here. 4.7 ohm, two ohms, 100 millihenry, which is 0.1 Henry, 100 milli, one ohm, and we have a capacitor here of 890 millifarad. And the question is, find Vx, and Vx is the voltage across the 1 ohm resistor, labeled plus on the top, minus on the bottom. Find Vx. Again, you got to sit down and decide, should I use nodal analysis, which is KCL, or should I use mesh analysis, which is KVL? Well, let's see. If you decide to go with nodal analysis, this is one node, we don't know what the voltage at. This is another node, I don't know what the voltage here is. This is a third node on the top, I don't know what the voltage is. So how many nodes do you have? This node, I know what the voltage is. How many nodes do you have? 3. How many equations are you going to have? 3 equations by 3 unknowns. If I do mesh equations, again, you can assign current anywhere you want to. I'll go clockwise. This is I1, I2, I3. How many unknowns? 3 again. So it really doesn't matter. I'll go with mesh just because we didn't do any of them yet. So I'm going to change this to Phasor first. So let me transform my circuit to Phasor. This source will be 4 angle 0. There's no shift there. The resistor doesn't change, still 2. 4.7. Two, 1, and the inductor. And this is Vx.
What do you want for omega?
Well, omega is given to us right here. Omega is 20. So the capacitor is going to be Z for the capacitor. The inductance of the capacitor is 1 over j omega c, or negative j over omega c. So if I take my calculator and plug them in, omega is 0.8, c is 0.890, so 20. 1 divided by 20 times 0.890. And if I did the math correctly, you can double check the math, negative j 0.056.
Is there any distinction between writing the j first?
Nope.
or after?
Nope. Yes, I'm not really a fan of writing it this way. I usually put the j at the end. I go negative 0.056j. I like it better that way, me personally. And this will be a plus j here because the value for the inductor is j over omega, j omega L. I'm going to say 1 over j omega C. That's a capacitor, j omega L. Too early, 8 o'clock in the morning. J omega L, which is j omega is 20, and L is what? 0.1 or 100 millihenry? Is that 2j? Positive 2j. Just want to take a peek at that when I copied that picture. Is that 890 milli? That's what it looks like it. Just a small value, you know.
Is this problem taken out of the book?
No, it's not really a problem in the book. It's just the homework at the end of the chapter. The picture similar to that. Yeah.
It's in like the very end of the chapter.
Yep.
Well, I know. I just think it's weird because a lot of the time the impedance values for the capacitors and inductors usually they're whole numbers. You know, they mean a lot of the time, but here, I mean, it's
Like this bugging of the fact is 0.056.
Yeah.
Yeah, in real life, a lot of times you have some funky numbers, you know. A lot of times you see small numbers. How can you get a 1 ohm resistor, 2 ohm resistor, 1 Henry? And that's what you call scaling. We'll get to that later in the course. You can scale that and it doesn't change the output of your circuit. Something called magnitude scaling and frequency scaling. We'll get to that later in the course. So now again, this is I sub 1. This is I sub 2. And this is I sub 3. Now I'm going to do KVL here, KVL here, KVL here for each one. I call this loop 1, loop 2, loop 3. So let's do KVL for loop 1. Kirchhoff voltage law for at loop 1. That's this one. It says if you take sum of the voltage in a closed loop is equal to 0. I'm traveling clockwise. And again, just like the question I got on my YouTube, people said, why'd you define the current going to the right? We said, we assign them any direction you want. It doesn't make any difference. Here, the same thing. I'm going to go in this direction, minus to plus. A lot of people, when they say minus to plus, they use plus. I use minus, just to be different. It really doesn't matter as long as you stick with it. So as I'm entering the minus end here, that's a negative 4 angle 0. Now as I'm traveling, it's going to mark this one what? Plus to minus. It's going to mark this plus to minus, and it's going to mark this plus to minus in this loop. Why? Current, just like water, goes from high to low. So if I have it go in this direction, I know it's plus to minus, plus to minus, plus to minus. So this will be a plus 2 times the current going through that. What's the current going up? I1. Plus, here we go, I'm entering the plus 4.7. Notice I define a plus to minus. That means I'm making the assumption the current's coming down. So what is the current coming down through that resistor? I1 pushing down. What about I sub 2?
Oh, I2 going the opposite direction.
So it's I sub 1 minus I sub 2. Plus the 2J. What's the current coming down? I1 minus I3. All of that is equal to 0. Clean that equation. 2 and 4, what's that, 6.7? 6.7 plus 2J times I sub 1. Minus 4.7 I sub 2 minus 2J I sub 3 is equal to what? 4 angle 0. That's equation number 1. EQ number 1, equation number 1. Now let's do KVL at equation 2, loop 2 right here. I'm traveling this way. Again, in this branch, since I'm going to the right, I'm going to mark this plus to minus, plus to minus, plus to minus. I stopped looking at the previous one. I'm going this way. So plus to minus, plus to minus, plus to minus. I'll start with that one. I'm entering plus to minus. That'll be a plus. The value of z times I. What is z? Negative 0.056j times what? I sub 2. Plus, continue here. This is 2 here. What is the, I'm going to the right to left. What's the current right to left?
I2
Keep going, Joe. I sub 2 what?
minus I sub 3.
Minus I sub 3. Keep going. Now we're going to get the 4.7. That's plus 4.7.
I sub 2 minus I sub 1.
I sub 2 minus I sub 1. Very good. Equals 0. If we clean that equation, negative 4.7 I sub 1 plus 6.7 minus 0.056j I sub 2 minus 2 I sub 3 is equal to 0. So if I added all the like terms, hopefully I did them correctly. That's my second equation. I need one more. Now let's do a third one. Now let's do KVL for the third one. That's the bottom one. That's down here. Again, I define it going this way. So plus to minus, plus to minus, plus to minus. So it's 1 times I sub 3 plus 2j. What is the current going up? Because I'm traveling up here. I sub 3 minus I sub 1, good. Plus the 2. I'm going to the right. What is the current through the 2 going to the right?
I sub 3 minus I sub 2.
Equals to 0. Clean it. For I sub 1, I see 2j or negative 2j I sub 1 minus 2 I sub 2 plus, what do we have for I sub 3? Is it 3 plus 2j? And that's my third equation. 3 equations by 3 unknowns. And you can solve them any way you want to. So let me take the 3 equations now and write them down nice and neat. on one page, so I don't have to flip back and forth through a couple of pages. The first equation reads what? 6.7 plus 2j I sub 1 minus 4.7 I sub 2 minus 2j I sub 3 is equal 4 angle 0. Second equation, negative 4.7 I sub 1 plus 6.7 minus 0.056j I sub 2 minus 2 I sub 3 equals 0. And the last equation reads what? Negative 2j I sub 1 minus 2 I sub 2 plus 3 plus 2j I sub 3 is equal to 0. Now, circuit is done. I am done with circuit. Now it's just math. How do you solve three equations by three unknowns?
You could use a calculator.
You can use a calculator if you know how. If you don't, you can use determinant, matrices, whatever method you want to use. Does everyone know determinant, matrix to solve them? Like if you want to find I sub 1, for example, you can make a I'm not going to do them there, I just use the calculator, but I'll set it up for those people never done. You write the coefficient. Negative 2j, negative 2, 3 plus 2j, 3 by 3. The top of that, we take this column out and put the answers. 4 angle 0, 0, 0, and these two columns stay the same. You can use Mathematica if you know how to use Mathematica. And that'll give you I sub 1. Then you can find I sub 2 and I sub 3. Now, lucky for me, my TI-86 here, it has simultaneous equation. If you have the 89, it does the same thing. I go simultaneous. This is how many equations? 3. And I can write my coefficient in complex mode. This doesn't care. 6.7 comma 2. So for the first value, 6.7 comma the 2. I gotta write them that way. Next one, negative 4.7. There's no imaginary. Next one, negative 2j. 0 comma negative 2. Next one, the answer, 4 angle 0. 4 angle 0. I can mix and match modes. Doesn't care. The next one, negative 4.7. 6.7 parentheses 6.7 comma negative 0.056 comma negative 2 comma the 0. Notice the negative 2. Look what the machine did. Did you notice that? I put negative 2. It turned it to what? 2 angle 180. That's what the minus sign does. The last one, negative 2j. 0 comma negative 2. Negative 2, the next one, is going to turn it to 2 angle 180 or negative 180. The other one, 3 plus 2j, because I have mine in polar mode. 3 comma 2 and 0. And I hit solve, and I got all the answers, I1, I2, and I sub 3. So what is I sub 1? Based on this, I sub 1 is equal to 1.446, and the angle is negative 3.24 degrees. I sub 2 is equal 1.3445. The angle is 1.07. And I sub 3, 1.1358, angle 12.16. Once I have all the currents, can I find what Vx is? What is Vx from that picture?
That's just I sub 3.
Times 1, right? So Ohm's law, Vx equals what? I sub 3 times 1, so which is 1.1358, angle 12.16 volts. These are amps, but that's a voltage now. That's a volt.
And we could just leave it in polar.
Sure.
Unless you specify to put it in rectangular, we can just leave it in whatever.
Well, if you want to put them in rectangular, here we go. You take your calculator, exit, you go to mode, and you say, I want a rectangular. If that makes you feel better, Joe, we'll put it there. I go, let me write that. 1.1358, angle, what? 12.16, right? Hit enter. And that's in rectangular mode now. 1.11 plus, because that's a positive value, the J is what? 0.239. Or you could have done it yourself by saying 1.1358 cosine 12.16 plus J 1.1358 sine 12.56. So if you don't have a calculator that does that, you can go 1.1358 cosine the 12.16 plus J 1.1358 sine 12.16. That's how you do them by hand. Let me try another one. We have time. We'll do mesh with this. Mesh really won't be a good one for this. Let me draw this picture first. .005 I sub 1, I think. I couldn't tell you. I can't even see it. So small. 70 millihenry here. $250 millifarad. We have a voltage source here. 9 cosine 20t. This is 3. Another capacitor here, 250 millifarad. Another voltage source here. Of 9 sine 20t. and it's 5 ohms. They want this problem done with mesh equation. Me personally, I would say probably not the best choice. They don't define what I sub 1 is. That's another problem. Look in here. Unless I'm blind.
What did you say?
I sub 1 is not. This is 0.005 I sub 1, but they don't tell you what I sub 1 is. The only I sub 1 they define is this I sub 1 for this loop. They're going to do a mesh equation. This is I sub 1. This is I sub 2. This is I sub 3. And this is I sub 4. So they're saying this voltage source depends on that current. Normally we pick a current in one of these branches based on that. Because in this branch, that current I sub 1, if this is I sub 1, this will be I sub 1 minus I sub 3 coming down. This branch is this 1 minus this. But they're saying based on that value, I sub 1, whatever I sub 1 is. So that forced you to do mesh equation. Ideally, as I said, this problem was not, mesh is not the best way to do it. And the reason I say that, how many unknowns do you see here? How many equations are you going to have? Now, if I change that to Phasor, and here's the good news, by the way. This is 20t, that's 20t. If this was not 20t, we saw that the first time, we have to use what method? Superposition. You got to do superposition, because when you say the capacitor is negative j over omega c, which omega are you going to use? Are you going to use this or that one? And you can't. So if these omegas were different, you don't have a choice. Superposition has to be the only way to do it.
And would that be like 8 equations by 8 unknowns?
Well, you can do it twice.
Yeah.
So it wouldn't be 8 by 8, but two sets of 4 by 4. You know? It's different.
Okay.
Yeah. So now this one is sine too. We don't like sine. How do we go from sine to cosine?
Add or subtract.
Add or subtract?
Subtract.
Are you sure?
Yes.
If you're not sure, Brandon, if you're not sure, pick an angle. Any angle you want. Like 30 degrees. You go, oh, t, I mean, pick a value for t. Let's say 20 degrees. Times actually, but it's not degrees really. But pick like 20 or 30. Let's say t is 30. What's 20 times 30? 600. What's sine of 600? Don't worry about the 9 in the front. Sine of 600. Oh, syntax error because I typed it wrong. Sine of 600. If I make t equals what, 30? Negative 0.86. Now if you make this 600, I mean t, we use 30, right? What's 20 times 30? 600 minus the 90. What's 600 minus 90? 510? Let's try cosine 510. See if the answer is the same. Yep. Notice if I made that addition, this would be 690, right?
Become positive.
So what's cosine of 690? So it's not the same answer. So that's one little quick test if you forget. If it's,
That's positive.
yeah, one's positive, one's
Oh,
negative. Yeah.
I see.
So if you're not sure if it's addition or subtraction, just pick a number for t, plug it in, and both them see with the minus and the plus. That tells you it has to be a minus. So if I switch that to Phasor, I'm going to use a, I'm going to just use a box there.
I like the boxes.
Yep.
They're nice.
Oh, I forgot to put a box here. This will be 9 angle negative 90. This will be 9 angle 0. This is I sub 1, I sub 3, I sub 2, I sub 4. And let me find the values for these. Inductor J omega L. Omega is 20, 70 milli, 0.07 times 20. That's a 1.4 J. Negative J over omega C. Again, this is 0.25 times 20. So 1 divided by 0.25 times 20. Negative 0.2 J. Negative 0.2 J. So we convert quickly to phasor. As I said earlier, I don't like this method. They want us with mesh equation. The reason I don't like this method, we know what the voltage here. This is ground here, right? The bottom. Do we know what the voltage here is? Do we know what that voltage? Yes. Do we know what that voltage is? Yes. Do we know what that voltage is? No. What about that one? Two unknowns. Would you rather solve an equation with 2 unknowns or 4 unknowns? 2. So I would have done that with nodal analysis. This is one node, there's another node. The current going in equals the current leaving. This rod should be a super node here. This here is all a super node. So you have 2 equations by 2 unknowns. But they wanted this problem done with mesh equations. Because once you start doing that, what is I sub 1? You don't know what I sub 1. You know this current, you know that current. It's not the same as I sub 1. Because this value depends on I sub 1 on that current. So let me do it with their method, and I'll deal with 4 equations, 4 unknowns on my calculator. Here we go. Let's begin with this one first. This loop here. Minus to plus, that's a minus. 9 angle 0. We're looking at this one. So this is minus, I'll go like this, negative 0.2 J, that's a plus.
I1 minus I2.
So the current going through it, I sub 1 minus I sub 2. Plus, again, I'm traveling this way, I'm marking this one, plus, minus, plus, minus. I'm traveling clockwise. That'll be 3 times what? What's the current top to bottom? Because plus to minus.
I1 minus I2.
Minus
I3.
I3. So if we clean that equation, I sub 1, 3 minus 0.2 J. I sub 2 plus 0.2 J I sub 2. I sub 3 minus 3 I sub 3. What about I sub 4? There is no I sub 4. 0 I sub 4 equals 9 angle 0. I put 0 because when I go to my calculator, I want to be able to look at these and type them in. Otherwise, I'll forget which one's which. That's the first equation. The nice thing about mesh equation, you're not dealing with the fraction. Null equation says this current, this voltage minus that divided by this, takes a little bit longer to simplify it. So this is really straightforward. And if you have a calculator that does the work for you, then it's not a big deal. Let's look at the top, I sub 2. I'm traveling clockwise. So I'm going to mark this plus, minus, the source plus, minus. I forgot to write the value of the source on the top. 0.005 I sub 1. So let's look at this one. Number 1. So this is mesh 1. Let's look at mesh 2. Loop 2 right there. That's 0.005 I sub 1 positive. This is 1.4 plus 1.4J. And since I'm traveling clockwise, what's the current down equal to? What's the current through this coming down? Yep, I sub 2 minus I sub 4. Very good. I sub 4 is going up. Notice I'm drawing it, the current going up. Continue with that. It's going to mark it plus to minus. Negative 0.2J. And what is the current going to the left? I'm traveling to the left, from right to left. I sub 2 minus I sub 1. Now let's clean it. We put them in order, the I sub 1 first, then the I sub 2, then the I sub 3s. So I have negative 0.2, so this is 0.005 plus 0.2 J I sub 1. What do we have for I sub 2? I got these two, right? 1.4 minus 0.2. Is that 1.2? Do you see any I sub 3 there? I don't see it. Do you see any I sub 4? I see 1. And that's the second equation. Now I need 2 more. I'll move this because I want to keep the picture on the screen there. Mesh 3, that's this one. Again, we're traveling clockwise. We're going to mark this plus, minus, plus, well, this one's already marked. And traveling this way. So we'll start with this one. That's 9, plus to minus, that's a plus. 9 angle negative 90. We're going to enter this, that's plus 3 times. What's the current going up? We're traveling clockwise, that's going up. I sub 3 minus I sub 1. Plus the negative 0.2J. What's the current going to the right? I sub 3 minus I sub 4. Again, let's clean that one. I have 3 I sub 1. There is no I sub 2 there, right? 0 I sub 2. Negative 3, yep, thank you. Now, we go to I sub 3. I got the 3 minus the 0.2J, right? What about the I sub 4? Is that plus 0.2J I sub 4 equals negative 9 angle negative 90. And that's equation number 3. One more. Mesh number 4. This one. Notice I'm traveling clockwise, plus to minus. I'm going to come this, going to mark it plus to minus. Uh-oh, this is backward. Can you see that? It's labeled plus on the top, minus. Plus to minus, plus to minus. I'm traveling this way. So I'll begin with the source. I'm entering the minus, so it's a negative 9 angle negative 90. It's backward to the way it was labeled. That's why it's a minus. Continue. Negative 0.2j. And I'm traveling this way. Notice I'm going through this loop. So I'm going to the left. What's the current to the left? Pushing this way. Is that I sub 3 minus I sub 4 minus I sub 3? It's going, I sub 4 is pushing this way, I sub 3 is going backward. Continue, now here we go, plus 1.4j. What is the current up there? I4 minus I sub 2, good. Plus the last one, the 5 with the current down, what's 5? I sub 4. Clean that. Do we have any I sub 1? 0 I sub 1. I sub 2, where are you? Right here, is that it? Negative 1.4 j I sub 2. I sub 3, positive 0.2 j I sub 3. And I sub 4, what do we have? 5 minus, 5 plus, right? 5 plus 1.2 j. Equals 9 angle negative 90. There's my 4 equations. Now I pull my calculator out. You can do them by hand. I got my friend here. My friend says, I want to solve these equations. This is, you know what? What I'm doing on my calculator here is like Phasor. It really is. What I did, basically, I'm the person changing that question to these equations. I'm going to give it to somebody who's really good in math, is going to solve them for me in Phasor. Then I take them back out of the calculator. So my job is to write these equations, give them to the calculator. This one says, I can do the math for you. And that's what Phasor, we take it from time domain, convert that to Phasor. There's somebody like the calculator that happens to be us who is really good in Phasor, is going to solve them quickly in Phasor and give us the answer in Phasor. Then I got to get it back and convert that to time domain. So I'm going to give my equations now to this calculator, because this calculator says, I can do the math for you. Oh, I guess I must have hit that key already. How many equations? 4. Here's the first one, 3 and negative 0.2. 3 comma negative 0.2. Negative 0.2. 0 comma 0.2, yes, positive. Next one, negative 3. Next one, 0. Next one, 9. 9 angle 0 is 9. 0.005. 0.005 comma 0.2. 1.2j, 0 comma 1.2, 0, 0 comma negative 1.4, 0.
So as long as you have the parentheses and the commas when you're doing the matrices, the calculator already knows that.
Complex mode, yeah.
binary numbers.
Yep, this calculator. Other ones are different, you put I in them. This one does, yeah. So this one, negative 3, 0, then I got 3 comma, negative 0.2, and the next one 0 comma 0.2. And this one, it's negative 9 angle negative 90. The last one, 0, negative 1.4j, 0 comma negative 1.4, 0.2, 0 comma 0.2, 5 comma 1.2, and 9 comma, parentheses, has been parentheses, 9 comma on this calculator, negative 90. Now I put the calculator in rectangular early, but that's your answer in rectangular. You can change it to polar if you want to, and solve now. And there's all the answers in rectangular mode. If I did it in polar, so I sub 1 is equal to negative 18.3 plus 20j. I sub 2 equals 5.1 minus 3.4j. I sub 3 equals negative 19.8 plus 21.6j, and I sub 4 equals 1.82 minus 0.02j. So once you have these, any question they want to know, we can solve it.
Do you want, I took it all down in polar. Do you want?
You have them? Sure. What's I sub 1 polar?
27.1 angle 132.5.
132.5.
Yep. The next one is 6.13 angle negative 33.7. The next one is 29.3 angle 132.5. And the next one is 1.8 angle negative 6.3.
I was looking to see if Joe typed them correctly, and basically, just judging by the angle, the real portion is negative, that's positive. Which quadrant are you in?
Second.
This quadrant, so your angle better be between 90 and 180, and it does match. This one, positive and negative. Positive here and negative. Which quadrant? Fourth quadrant. That's what it tells me, in the fourth quadrant. This one, negative and positive, second quadrant. Yep. This one, positive and negative in the fourth quadrant. Yep. So I'm trying to see actually if we match our answers, if what I type and he typed, we type the right values. That doesn't say we're 100% right, but it just says at least there's a good chance we match him, because that looks like he gave me the answer what I got. I got an answer in the second quadrant, he got an answer in the second quadrant. I got one in the fourth, he got one in the fourth. I got one in the second, he got the one in the second, fourth, and he got one in the fourth. So a little just spot check to see, you know, if we were doing okay or not. Okay, so this is really what Thevenin and Norton, the same things we did before, except the math. Where it becomes really a nightmare if you have to do the math by hand. That's the problem with it. But if you have one of those calculators, then it's not bad.